What we have here is another identity, and looks like we're going to benefit from at least working the left-hand side and trying to make it into the right. The right-hand side looks very concise. So one strategy that we can use when simplifying expressions is the idea that everything boils down to sine and cosine. So I'm going to start by rewriting those two. So again, using the left-hand side, it seems like we always make these problems where we start with the left, just because we are kind of a left to right world, I guess. So secant is 1 over cosine, and cosecant is 1 over sine. Now at that point, I'm going to multiply. Now we have a complex fraction, so I'm going to multiply by something that's going to wipe out all the fractions. And that looks like sine x cosine x. So let's see what happens after we're done there. So if this gets distributed to the numerator, actually I'm going to leave it factored for now until I figure out what we're doing here. So we have sine x, actually I will multiply it out. So we have sine squared x cosine x plus sine x cosine squared x. I'm not quite sure where I fall on this yet, but we'll see. And then if I distribute the sine x cosine x to the denominator, it looks like we have sine x plus cosine x. Okay, so lesson learned. I should have kept the numerator factored. So here we go. Factoring out the sine x cosine x, we have sine x plus cosine x, all divided by, sine x plus cosine x. And cross out the common factor. Look at that. So we're down to sine x cosine x. Well, if you remember the identity for sine of 2x, this should hopefully look familiar. Just to double check, though, I am going to take this side and I am going to rewrite that as well. We know that sine 2x is 2 sine x cosine x. And yeah, wouldn't you know, the 1/2 and the 2 cancel out. And there we have it. Sine x cosine x on both sides. So we have verified this identity. And again, left side looks horrid, right side looks nice and simplified, and we could definitely analyze the right-hand side better than the left. So this is why we prove identities. Thanks for watching, and come back for more examples.